I adjusted here. The same graph, we will study the what are all possible things we can find out from it. Now look at the experimental curve. It was first then it was here like this, no? For 4 seconds, 2, 4, and this was 8, and this value was 10. This was the velocity versus, and this is a time interval. X-axis was time, and on the y-axis we had the velocity. Okay, what is actually how that motion takes place? So first it will accelerate, then it will undergo uniform velocity motion, then it will undergo retardation. Physically, how do that motion occurs? Some students are asking, sir, how that motion of an object will take place. Our car, whatever be that, if a vehicle or somebody is moving, so how that motion occurs. So for first 2 seconds, here the body will accelerate. The body will move with a constant speed. Here the body will undergo retardation. Okay, this is A1. Okay, this is A5 something, whatever be that. So look at the motion of the body. First it will accelerate. It will start from rest. There's a physical one. It will start from rest and it will come to rest. First it will accelerate. It will accelerate from rest, uniform velocity motion, then undergoes retardation, and finally comes to rest here. So the motion first, it will accelerate, uniform velocity motion, oh, very small, no, till here. Then it will undergo retardation afterwards. So the motion, in fact, will occur like this. This is the acceleration, uniform speed or uniform velocity. Then retardation, and finally comes to rest. See, it is simple. You start the bike, you increase the speed, move with a constant speed, then put brakes and come to rest. This was this motion. Okay, what about the position versus time graph? I think that is also very important, which we should plot. How the position versus time graph will be. This is 2, this is 4, this is 8. First, what will happen to the body? It will accelerate. Then it moves with a I'll try to draw the graph to the scale. Yeah. Then afterwards, it will undergo retardation. Oh, yeah, I'll try to retardation. It should be like that. And finally comes to rest. This is, I'll put dots where the change in motion occurs. So what is this? This is a position. Position. This is time. 2, 4. This is 8. Okay, how do what is this, sir? How do you can say how you can plot this graph? It's an accelerated motion. S equal to half AT square. So therefore it should be a parabola. S equal to half AT square. Then straight line, uniform velocity motion. It must be a straight line. Huh? I don't know how it is. Is it a straight line? I'll draw it. I'll draw it. Yeah. Uniform velocity motion. And afterwards, it'll undergo return. Look at the slope. The slope keeps on decreases. No? And in ST graph, if you calculate slope, what do you get? You'll get the speed or velocity. So slope decreasing. So therefore, it is said to be undergoing the retardation. Acceleration, the curve will be like this. Parabola, this is also parabola. This is a straight line. This is what happens in position versus time graph. It's a curve. It's a parabola. This is also a parabola. This is a straight line. See, so much of information we have in this VT graph. The ST graph will appear like this. So we must be in a position. If they give VT graph, we must be in a position to plot the ST graph. So what is the type of motion? The body here it will undergo retardation. You calculate slope at various points. So the magnitude of slope keeps on decreases. Okay, this is one overall generalized idea about the body retardation and acceleration. Okay, this is one background is what needed. Okay, after this, so one more information. In ST graphs, what do this? The curves will indicate the different shaped curves. The first curve, I'll bring like this. So then, so this different shaped curves, what is the meaning of that? So that I think this background, if we have no, it'll be very easy for us to. Okay, then I'll do one thing. I'll give it from here. Okay, here there's a curve. If somebody plots a position versus time graph, it is. Look at the different parts of a curve. What does it mean? The slope of a curve, you see that keeps on increasing. So it is said to be accelerating in forward direction. Okay, towards right, I'll take positive. So what do you mean by slope? Sir, I'm not understanding you're saying slope. Okay, we'll do one thing. Is it visible? Okay, that I'll make it a little bit thick. Look at the, I'm drawing the tangent at 2 different points. Point 192. Let's indicate 0.192. What will happen to the slope at 1 is more than 2. And it's positive, no? V1 is positive, V2 is positive. And what is another conclusion? V1 greater than V2. So with this, what we can say from O to A, speed of the body increases. Speed of body increases. So what we can select, accelerated motion. For O to A, what is the comment we can put it? It is accelerated, describing accelerated motion. I think I need a lot of space. And I'll push it a little bit up. Yeah, this will be sufficient. No. Speed of body increases. So from O to A, the speed of the body increases. So shall we say, what is the type of motion? Accelerated motion. Accelerated motion along positive x-axis. The body is moving along positive x-axis and speed is increasing. Next, afterwards, A to B will see. Again, to analyze this, we'll draw a tangent at 2 different points. Again, we'll draw a tangent. So one tangent I'll draw here. The other tangent I'll draw here. Look at the angle made by the tangents. Look at the green dots here. So look at this tangent and look at this tangent. So the angle made by this tangent is more than this one. So this is 0.3, 0.4, you write it. So again, the slope of tangent drawn in ST graph will give instantaneous velocity. Am I right? Go back, long back, we have discussed previous classes. So therefore, so what is one more conclusion? V3 is positive, V4 is also positive, and magnitude V3 greater than V4. So what's happening to the, sorry, V4, so V3 greater than V4. So V3 will be greater than V4. So what's happening to the slope now? Is decreasing, no? Earlier slope was increasing. Okay, this is, it's like this. Speed of particle is increased, speed of body increases. The symbols little bit change. Slope at 2 more than 1. So the speed of the body keeps on increasing. So it is said to be accelerating. No, slope at 3 more than 4. The angle made by tangent with horizontal will be here less, or for your L, I will indicate that angle also. Theta 4. So looking at this, you can directly write it, no? Which angle will be more? Theta 2 will be greater than theta 1. Agreed? Similarly here, V3 theta 3 will be greater than theta 4. So therefore, the magnitude of slope decreases. Slope of tangent drawn in FT graph will give velocity. So the speed of particle is decreasing. So what is the type of motion AB? For AB, what we can write? Speed of body decreases. So what we can write it as? Retarding motion along positive x-axis. Body moving, speed of body decreases. So what is the type of motion? Retarding motion. Retarding motion along positive x-axis. Just, I think, will along positive x-axis will later on will indicate. I'll show that. So retarding motion, accelerated motion, that will indicate. The direction I'll show by another graph. So there's the first thing, the second thing, third thing will analyze. Third one for BC. For the part BC. Okay, we'll draw again a tangent. I will draw a tangent here. Then I'll draw a tangent here. Look at the tangent, they're negative, no? Okay, these are the points 5 and 6. 5 and 6. Slope is negative. So velocity will be directed towards left. So that I read. So here V5 is negative. V6 negative, but slope at 6 is more than that at 5. Magnitude. So what's happening to speed of the object? Is increasing. So BC, what we can say? Speed of body is increasing and it is said to be accelerated motion. In what direction? It is moving towards light. It is moving towards left here because V negative. V negative means it is moving along negative x-axis. That I'll indicate in the other diagram. There's a fourth one. We'll explore the last one. Color is needed. Yeah, now the last part, CD. Again, we'll draw a tangent. Okay, this will be 7, This will be 8. So slope at 7, it is more than that of 8, no? So for 4, what we can write it as V7 is negative, V8 is negative, and V7 greater than V8. Theta 7. Similarly here, theta 6. So speed of body decreases. Slope, magnitude of slope decreases, speed of body decreases. So what type of motion? Retarding motion. The body describes retarding motion. Okay, this is something very, very important. How do that motion takes place? In fact, we have to study the motion of this object, no? How did that motion takes place? Okay, let me take one more fresh page. I was here, no? Now, how did that motion of object occurs? Okay, everything I think